is, oh, thanks for that, Francisco. We're recording now. So yeah, your operating system is ultimately just the one program your computer is running, but it's such a powerful program, it allows you to run other programs and do all of these other things. And so the topic of today is essentially your operating system and this idea called Unix, which is sort of a common philosophy of operating systems that now that you're either on Mac or you're on Linux or you're on Windows with WSL, and all those are versions of what we would call a Unix environment. And then we're going to learn a little bit about how that all is set up, sort of the architecture, the basic architecture of Unix, so we can understand why things are the way they are. And then we're going to spend the majority of the time learning the most essential commands for interacting with your OS, what we would call interacting with your operating system through a command line interface, which is what the various terminal programs you have on your computer now are doing. And this last part is actually outdated because we moved that to the next day. So we're not actually going to talk about Git or GitHub today. So I should remove that line. But today is really just about the operating system and working with your operating system through command line. Okay, so this first part is just the install fest stuff, which you should have done by now. But if it's not complete, that's fine. We will, that can often take up to a week if you're having weird little issues. Okay, so our first question is, what is Unix? So I don't know that I want to go into too much details of this because you could see there's a lot of details. But at the end of the day, when we say Unix, we're talking about your terminal. So this terminal right here, where I can say, ls, and we see all of our files and folders, or, I can write pwd. We'll explain this stuff, but PW means print working directory. So I'm going to see that's exactly where I am on the file system. All of that is part of your terminal, and how this all works, whether you're on Mac or Linux or Windows with WSL, this is what we generally refer to as Unix. So what is Unix? Without getting into the details, it's an operating system architecture and a set of tools that allow a user to interact with that operating system through a command line interface. So there's a lot there, but essentially your computer is a very complex tool and you have this interface for it called an operating system. And because this idea goes back so long, like in the detail section, we see like this very concept of Unix architecture started at this place called Bell Labs in the 1960s. It's a very old idea, and it actually predates a mouse. So the idea that everything can be done by typing things in your keyboard it might seem obtuse at times, or not as usable as something like a graphical interface. But this was the original way you would do anything, because originally there was no mouse. You just typed everything in. And so something to understand is that your command line interface can do everything on your computer. You might not know all the commands. It might seem obscure how to work with it at times, but this is just as much capable of doing everything on your computer as, opening up Finder or, opening up a specific file and all the programs that are in there. And what we're going to work on today is learning how we use this environment. So not really going to worry too much about the details, but for a long time, like Mac is kind of pretty close to Unix, but it's closed source. Linux is an example of Unix, but it's open source. And Windows for a long time just went its own way. What they call security by obscurity. Windows just did it a weird way that no one else knows how to do it. I actually worked at Microsoft on Windows, and I'll tell you, this part of Windows, it's locked down. Like 10 people have access, and people say like, hey, there's code in there from the 70s. No one knows how it works, but that's how it works. And that is an approach that made it kind of a terrible development environment for a long time. But luckily we have this thing called WSL now, which is essentially means you get to use a version of Linux on Windows. And so as a result, everyone, whether you're on Linux or Mac OS or Windows, we're all using approximately the same operating system now. There's small differences, but it's approximately the same environment. So before moving on, I do want to stop and ask questions. And I do want to say, because this is the first lecture, sometimes I can go a little fast, and I do want to get feedback to slow down with things. And just in general, there really are no stupid questions with this stuff. No one knows how all of this works at this point. There's so many layers. Even if you know a lot, you don't know everything. And so there's really no dumb questions here. And in reality, the dumber the question, the better it is. Because if you can ask a really dumb question and you get the answer, there's a simple answer, well, then now you know that answer forever. So dumb questions are very good. And like Rod said this morning, you should get comfortable exposing your own ignorance, because it makes you better at learning things. So is there anything we want to ask about before we move on to actually talking about what Unix is?
Sorry, just to clarify, so Linux and WSL and Mac OS are all the same sort of thing as Unix, or they are? Sorry.
Yeah, no, that's a great question. I'm talking about it a little hand wavy because the reality is Unix is a specific operating system that was invented in the 60s, and because it was open source, this is in this whole the detail section. Because it was open source, people just copied it, but because people copied it, every version works slightly differently. And Linux basically represents that tradition where every flavor of Linux is slightly different, and anyone can take it. Anyone who really knows what they're doing can take it, copy it, change it slightly, and call it, Benix or something. Like you yourself can make your own version of Linux just by copying someone else's. Whereas Mac OS is very, very similar to Linux, and so we call it Unix-like, but it's closed source, so you can't actually copy it without getting Apple's lawyers to hunt you down. Even me saying this, they're probably listening. And then Windows, it was its own thing called MS-DOS, and that's how Windows actually works. But modern Windows with WSL is running Linux on top of Windows. And so when I say Unix, what I mean is that we all have access to this terminal now, and you can type things like ls, and that will list you your files. You can type something like cd, and that will go into a file. And just that common language of being able to use the command line, that's what I mean when I say Unix. But that's a great question. Okay, so I think I'll move on for now. And before we get into specific commands, I want to talk a little bit about this idea of the architecture of Unix. So if you think about it, your computer, the whole thing, it's kind of like any machine. You press start and it starts running, and that's what it does. And until you pull the plug or turn it off, it's going to do that one thing. And early computers were like this, where they just did one thing, and you could feed it a program and it would run the program, and that was it. But eventually people came up with this idea of an operating system, and an operating system at its core is simply the one program your computer runs by default, which is such a complex program that it allows you to run other programs. And what that means is it's essentially like a kind of scheduler. And your operating system is like this, supervisor that's in charge, and other programs come up to it and say, hey, can I get a little time to use the hardware to actually like run? And then the supervisor that is the operating system can say, yeah, you have 5 minutes. And so let's say you're on a web browser looking at a website, and you're also listening to music on Spotify. It seems like you're running two programs at once. But in reality, what was that? Someone talking? Never mind, I thought I heard something. In reality, your computer is not, at this point in history, it might have multi-cores. Maybe it really is running two things at once, but in reality, your operating system is generally the only thing running. And then your web browser says, hey, I need to do something. Can I get a few seconds? And then in less than a second, your it's done doing that, and then Spotify says, hey, I want to play some music. Can I get a second? And your computer's just jumping back and forth between all these different tasks, but really it's only doing one thing at a time. And to understand how this whole thing works, it's worth diving into this basic little architecture thing. So you see we have these layers, and it's like concentric circles. So at the very center, we have the hardware. Then outside, we have this thing called the kernel. Outside that, we have this thing called the shell. And outside this thing, we have this thing called applications. So what are those? The hardware is the literal hardware. So every single piece of your computer, every physical piece of it could have been made by a different manufacturer. And if you're on a Mac, well, Mac actually kind of makes all the pieces and makes sure that they all work well together. But if you're on Windows, Windows actually, or even Linux, they both have a much harder problem to solve, which is anyone could have made any of this hardware. How do we make sure it all works together? And if you've ever heard of the word a driver is essentially a program that at a very low level understands how your hardware works, in the terms of electricity. And that's a very low level that most people are never going to touch. It's so specific. So there's the hardware, but then wrapping the hardware is what we call the kernel. And it's called that because just like a popcorn kernel or something, it's the most essential layer that is now software. So the kernel is the software that runs the hardware, but it's very low level stuff that's concerned with like scheduling, or having the memory talk to the hard drive, talk to the CPU. And all that stuff is still so low level that the average user never will touch it. So the analogy is sort of like the hardware is like, maybe like the tires and the body of a car. And then the kernel is like the engine. It's the first layer where it's like, oh, this sort of ties everything together. It makes everything work, but it's still kind of the domain of an expert. The average person doesn't really know how to fix their own engine of their car. So then the layer after that is the shell. And the shell, if we look at a terminal, this is what we mean when we talk about a shell. So if you're on Mac, you're using this thing called Z shell. I'm actually already in there, but if I do that, you'll see it just does the same thing. I'm in what's called a shell. ZSH is Z shell. And if you're on if you're on Windows, you're likely on this thing, or Windows or Linux, you're likely on this thing called Bash, which stands for Born Again Shell. I don't know where the naming of these things comes from, but it's another shell. And they're all slightly different, but basically the shell is how you, the average user, is going to interact with a computer without having to know that, this is how the CPU works and this is how to talk to the CPU. Instead, all that's been figured out by the kernel, and now the shell is how the user interacts with the kernel. Let me sorry, I'm just cleaning this up a little. So right, going back,
just like a translator kind of in between you and the computer.
Exactly, yeah, they're all kind of levels of translation where like the hardware is, literally if you yourself as an individual wanted to control the hardware, you'd have to be shooting electricity through your fingers and saying like a little bit of electricity, no electricity there, a little bit of electricity, and that's too low level. And the kernel is one layer on top of that, which handles, talking to the hardware in electricity, but it's still so low level. And the shell is the first layer where you could say, I could say ls, and so much happened there. It knows about this concept of an operating system. It listened to my keyboard. It spoke to a screen. It printed something to the screen. So much happened there. And all that stuff is being, like you said, like translated for us. We just type ls and it's orchestrating all this hardware stuff without us having to know the details, because the details would be too complex for anyone to get any work done that way. Yeah, I'm just curious. Were you one of the language people in the military?
What gave that away?
Yeah, no, but it is a good way of thinking about things, because as we get more into it, really that's all software is. Software is language to control physical stuff, but language is the main interface. So, and actually artificial languages like computer languages are simpler than natural languages, because natural languages have this thing called ambiguity, and I could say something and you could interpret it differently, and that's actually a function of natural languages, but computers are too dumb to do that. Yeah, great question. Okay, so that's the shell. And the shell, I would say in our analogy with like a car, the shell is sort of like the steering wheel and the gas and brake pedals, where you don't need to know how it works at the end of the day, but that's your interface. And someone who doesn't know how to drive a car, they don't know how to use the shell. They can't drive a car. But if you know how to drive a car, what that means is you know how to use the shell. You don't necessarily know how to fix an engine. You can't really, do body work, but you can control the car, and that's what matters. And then this final layer is what we call applications. So basically, if all we had was the shell, all you could do on your computer was, things that already came pre-installed on it. You could create a folder, you can create a file, you might put text in that file, but it's sort of limited, and you really want to be able to a computer should ideally, or an operating system, if it's powerful enough, should ideally allow other people to create applications for it that can now be run on your computer. And so in terms of the GUI version of that, you have like the App Store or you have the Windows Store. But in the terminal version, that's something like, Brew, or you kind of use a pre-existing program to download another program, and then that program can download other programs. And so when macOS was created, it had no idea about Python. Or at the very least, when Python was first invented, macOS had no idea about Python. It wasn't designed to make Python work, but it was designed so that it could run arbitrary programs. And so someone invented a program called Python, and that program runs a certain way. And whoever makes Python actually has to know a fair amount about that kernel level, because it really needs to know how does a computer work. But at the end of the day, it means that you, the shell user, can just type Python, and now you have a programming language, and you can type 1 + 1, and you don't need to know that it's like storing that in memory somewhere and talking to the CPU and all the details about how a computer actually works, which virtually nobody knows anymore. All right, and just to complete the analogy, we have hardware, which is like the physical body of the car. We have a kernel, which is like the engine or the drive shaft and other things that are kind of the domain of the expert, even if they're not like, even if technically you could learn how they work. And then the shell is the steering wheel and, the gears and the pedals, and that's how you, the average user, would use it. And then applications is sort of like how, your car might have like a place where a radio can go or a GPS can go, and it doesn't know who made the radio or who made the GPS, but the car was made so that it's plug and play. Other people can make things that go in there. All right, so before moving on, any questions about this general idea of architecture? And I'll just let you know, you don't really need to know this stuff super well. It's just to help maybe understand why things are the way they are. Okay, I'll look at chat real quickly. Heated seats. Okay, well, if we have no questions, we'll move on. And what we're going to move on to is basically, now that we understand the sort of architecture of it, let's just zoom in on the shell and say, how does it work? And it actually is sort of simple in a way, in that as far as your shell is concerned, there's only two types of things: files and folders. So your shell is really there to access your file system. And in your file system, everything is a file or a folder. And this is sort of part of the Unix philosophy, which is just that things should be as simple as possible. And then you make things complex by combining things. But at its core, everything should be as simple as possible. And so this is sort of a demonstration of what that might look like. You can have a file, and a file can contain files, or sorry, you can have a folder, that's my circle, and a folder can contain other things in it. So it can contain a file, or it can contain another folder. And folders can contain files, but files are themselves a file, maybe you could say it contains text, but a file is sort of the leaf of the tree, whereas a folder is, a branch of the tree. And a folder could be empty, but a file is a thing. So for example, here I have some folder, it contains a bunch of things, contains these two files, then it also contains another folder, and that folder contains nothing. And I just wanted to show you this sort of like drawing syntax where you'll see this sometimes, and that means it points to nothing. But yeah, it's all here. A file is a thing, and a folder, or a directory as it's sometimes called, contains 0 or more things. So if I look here, just looking at my own operating system, if I type ls, that's like ls stands for list. Just as a quick explanation, a lot of these commands have very esoteric phrases, like why is it ls? Why isn't it list or something? There's kind of two reasons for that. The first reason is that you type it all the time, so it's nice that it's short. The truer reason is that if you go back in history, computers had so little memory that they didn't want a command that was called like, where am I? So they said, oh, we're going to call that print working directory. And so as a result, you have a lot of these very hard to decipher commands, and you just sort of learn them over time. So clear is one that's going to clear the screen. But just to show you the basics, like, and you see that squiggle there? That squiggle means I'm in my home directory. And that's why if I say print working directory, that tells me exactly where it is. It tells me at the root, there's this folder called users and a folder called Benjamin Cohen, and that's where we are. And then if in that folder I type ls, I'm going to see all of my files and folders here. And I think you can kind of ignore that some of these are pink, but basically all the white ones on my system are folders, which means there's something inside of it. And if I were to say like touch hello.txt, and we'll get to all this, but that just creates a new file. So I'm going to do that. Now I type ls, and you'll see, okay, so now in not bold, I have a file called hello.txt, and that's all there is. So if I went into documents, for example, and it wants access, so I'll click OK. But now I can see, okay, I have some files there. I have some folders there. I don't know if you have this on Linux or Windows, but on Mac, you can say open. So I could say, open resume, and it's actually going to know enough to like open the right program. But at its core, all we have is files and folders. And you might ask, like, what is something like open, or what is something like cd? Well, we call those commands. But the kind of crazy thing is, at the end of the day, those commands are just programs, and those programs are just files. So as you saw in that in our install fest, I have this one command called which, and which is going to tell me where something is. So I could say something like, ooh, I wonder, will this work? Which CD? No, because it's built in. But I could say like which Python, right? Alias to Python 3. So which Python 3? And now if I try to open that in Visual Studio Code, so I'm going to go right to that, which is sort of nuts. Let me get this out of here. But if I try and go right to that file, I'm going to open it in Visual Studio Code. And it says, this isn't designed for a text editor, open it anyways. Okay, so it looks insane. It looks insane because it's trying to read ones and zeros that are not designed to be read this way. But it is just a file. It's just a file. It contains stuff. In this case, it contains binary. It contains ones and zeros. And the computer really likes that format because that's how the computer thinks of things for running a program. It's getting very confused trying to turn this into text for us. But it is worth noting, every command is just a file. And if something's not a file, it's a folder. It just is a thing that can contain files and folders. Okay, so yeah, before moving on to the Unix commands, and maybe we should talk about this a little more and then take a break. But any questions, just anything we could possibly want to ask about the basic environment we're in before we're learning specific commands in Unix. I'll look at chat.
How did you get the pink color on
It's a great question. So we get to this in the specific commands thing, but that so the fact that there's colors or not, that's why you use something like oh my Z shell, or colors are not even default in command line stuff, but colors are there because they can kind of tell you what something is. And we get into this more in the specific command prompt stuff, but if I typed ls, that shows me all the files, right? And if I type, and what I'm doing right now is adding a flag to it. So ls-l, I don't know why it's -l, but that is going to show me all the files and way more information than you could ever want to know about those files. So this looks nuts, right? And I don't know how to read a lot of this either. You really got to be a Linux head and know to, like, basically this is who I am, and this is some like group I'm part of, and this is the last time the file was modified, and this is the name of the file, and this is like how many bytes the file takes up or something. And this insane thing to read here, if it has a D in the front, that means it's a directory. If it has a blank, that means it's a file. And then all of these other things tell you what kind of access rights you have. So read, write, execute. If it's a program, that's a file that can be executed. If it's a regular file, maybe that's a file you only have read access to. And maybe if you have the right password, you have write access to it. You don't need to understand everything here, but you'll note that if we look here, those pink ones, they point somewhere. And if we look here, we see an L, that's because that's what's called a link or a symbolic link. So the reason I have those is because I really want things to live where they should live. So maybe I have this folder called source, and in source, I have something like machine learning. And in there, I have something called, neural nets 0 to hero. And let's say I want quick access to that. And we do get into this. Oops, I don't know what I did there. We do get into this a little more in the specific commands thing. But if I wanted to make a link, i.e. just like making a shortcut on your desktop, I would type ln, which means link, -s for symbolic. Again, I barely know why these are the letters they are. And then I would say, well, actually, I have a specific file. Maybe I'll go in music, and who knows what is in music? I don't even know. That was a bad choice, music. I don't know what's in there, but I could go anywhere on my file system. Let's say I would go to, source, and then I would go to code Platoon, and then I would go to Tango, and then I would go to grading, and I would go to assessment 2. So like I could go as deep as I wanted to go, someone's specific assessment 2, and let's say the README from there, or let's say the whole folder. And then I'll say, okay, actually where I am, I want to call that students assessment 2. Now, if I type ls, I have something called students assessment 2, and it's the same thing as it points to that other one. So I now have access to it up here, but I didn't really move where the file was. The file still lives where it was, but now I have a link to it. So that's what that is. But we will get into that more in a second when we talk about specific commands. Any other questions about just general Linux stuff? I see there's a question in the chat about, do we need, oh, sorry, go ahead.
I was going to ask, so if you make that shortcut there and say you did the remove function, that's not going to remove that from that folder. It's just going to remove your shortcut, correct?
Yeah, that's a great question. And
Okay.
maybe it wouldn't work that way, but as it turns out, that is how it works. And just like you saw that remove thing, remove can do more than a couple things. So if I look here and I remove that student assessment 2, it's now gone from here. But if we looked into where we got it from, the original is still there. I didn't delete the original.
But if you did it now, again, would that delete the original?
Well, only if I did it exactly where it actually
with
is. Right?
the huge file path. Okay.
Yeah,
Yeah.
yeah. And I could do that. I mean, I literally could because it's a student who, you know, doesn't go here anymore. So I could go all the way to code platoon. It was Tango, grading, assessment 2. And by the way, I'm doing this so quickly because I'm hitting tab. Tab will autocomplete for you. Right, so let's say I go all the way here. Now I have these things. Now I could say remove, you know, project 2, 84. But I believe what's going to happen is if I do that, it's going to say, what is the error? It says, sorry, that's a directory. So it's not that easy to delete something that has stuff in it. It will warn you. And that's why then we would give it, you know, some flags. And these flags mean forcefully, meaning don't ask me any questions, and recursively, meaning I know it's a folder, delete folder and everything inside of it and everything inside of anything inside of it. And now if I look at it, it's just not there anymore.
Yeah, I guess that when you put in a link, if you put like hard link without like S flag,
Mhm.
if you delete the link itself, it can delete both files. If you put like soft link, like flag S, means just deletes the actual link.
Oh, and what's the hard link?
Hard link, it just points to the same location, the same file. It's just you're gonna have like extra handler for that
Yeah,
file.
but how do I make one of those?
Probably without M,
-N?
without the flag, without flag,
Okay.
without any
But,
flags.
oh, without any flag, right? Got it. Okay. Yeah, and that's an interesting thing about this stuff. Like I didn't know that, and there's so much you could possibly know about this stuff. That what we're going to teach you today are the essentials. But like for any one of the stuff, and this is a terrible. It's not a very usable way to learn stuff. But there's a program called MAN, which stands for manual. So I could say something like man and ln. And now look at this. You'll see there's this is the manual for ln, and it tells you, okay, what does it do? It links files. And then this is very hard to read, but it's trying to tell you this can do so many things. And now walk through it, not with a mouse, with, you know, your up and down arrow, because that's all it understands. And it's going to tell you every single flag it takes and how that modifies how it works. And that is like, these are powerful tools that can theoretically do a lot, but most people don't understand all this. Like I'm never going to read all that. I don't want to. And while we're here, we might as well show you, we do explain this, or we do talk about this a little more in a minute. I'm trying to get, why isn't this working? I'm trying to, hey, I'll do it like this. Oh, I see, it's covered. So we have this link for you as well, but there's something called explain shell. There we go, explainshell.com. And in there, you can type in any shell or any shell command and it'll tell you stuff. So I could say like ln -s like A, B, and then it'll tell me, okay, this makes a link between files. This makes symbolic links instead of hard links. And then it's telling me, you know, one of these is like the target and the other is the source or something like that. And so if you ever have any doubt about a shell command, this is the way nicer way to learn about it than actually the man command in your command line. So, you know, cd, yeah. But a lot of the stuff you just sort of like, you learn the basics and then that takes you a pretty long way. So any other questions about this basic stuff before moving on to the commands? Because the commands we will really, you know, there's a bunch of them and we'll just talk about that for a while. If there are no other questions, I feel like it would be, I want to give you guys like maybe a 10-minute break and then we'll come back. And then as you could see, there's a lot of commands to discuss. We don't expect you to really know all of them, but these are the ones we're going to go over. So yeah, let's take a 10-minute break and come back at what will be 1:55 CST. Right, thanks, Francisco. So for the rest of this lecture, we're going to just be talking about these basic commands to, well, basic and then some more than basic commands to work with your operating system from the command line. So some of these are more essential than others. Some of these you'll see more than others. Some of these we just want you to know about, even if you won't use them regularly. And so we try and break them down into these like sections. So, and there's a little disclaimer here, which I mentioned earlier, but basically these commands can sometimes have, they can sometimes be acronyms or be so concise that it's like annoying in the learning phase, but you appreciate it over time that they're so short because you use them all the time. And they're your means of like, moving around. So like if there was a LS or a CD key on the keyboard, you would appreciate that because you're using it all the time. So this first one here, I feel like it's just worth pointing out because it's such a simple command. PWD is print working directory. So if I go to my shell here, if I do print working directory, it's going to show me exactly where I am. I'm at /user/Benjamin Cohen. And then if I went to, let's say I went into source, and then I went into code platoon, I could do that again, and it's print working directory, and that's where I am. We discuss this more in a minute, but this slash here represents the root of your system. And anytime you do print working directory, it's going to tell you where you are based on the root. But the root is, because it's as high up as you can get in the file system hierarchy. So there's other shorter things that you sometimes see, and one of them is squiggle or tilde, which should be right below your escape key, right to the left of your 1 key, and that's your home directory. And the idea there is that if you're on an operating system, maybe you're not the only user, maybe there's some other users, and so you don't necessarily want to be at the root all the time. You want to be at squiggle because squiggle represents you. And print working directory will tell me exactly where that is. But if you're using a modern terminal, it's just going to show you where you are over here, which is why you almost never actually see people use print working directory. Just a good one to know about. But yeah, this is where we are right now. We're at our home directory, which for me is /user/Benjamin Cohen. And the next thing to talk about then naturally is ls, which is list. ls is going to list everything in the current directory. So pretty simply, ls, that's everything that's currently, or in the current directory I'm in, which is, squiggle or /user/Benjamin Cohen. ls is going to print all the files and folders in that directory. And ls and cd, which we'll get to in a second, ls list what's in there, change directory, move to a different directory. That's your bread and butter. That's how you move around the file system in a CLI way. And those are the ones you're going to use constantly. And the next thing we talk about is ls-a. So we wanted to show this to show the first example of what we call a flag. So PWD is a command, and that's it. The command takes no arguments, we could say. ls is a command. When we type ls, it takes no arguments. It's just ls, that's the whole story. But sometimes it takes arguments, and some of these arguments are specific where they're what we call a flag. If it starts with a dash, we call that a flag. So you might have seen earlier in the install fest, like if I type node, that's going to show me, that's going to actually, run node. And now I can do, 1+1, but that's not the only thing I can do. So if I type node and then I type something like -v, that's going to tell me the version of this version of node I'm using. And then very often you'll see this. This is just a convention, the dash. So -v, but part of this convention you'll also see, you'll have something like -v, which is the short version, but you'll also have -- like version. And that'll be the long version, and it'll be the same exact thing. It's just that -- version is more human readable, and -v is more, you do this quickly. But in this case, we're doing ls-a. And I don't know what it actually stands for, but I'm gonna guess -a means all, right? Because what ls-a does is that's going to show me all the files. Well, doesn't ls show me all the files? Yes and no. ls shows me all the files and folders in the directory I'm in. But what it doesn't show me is hidden files and folders. And by convention, in any version of Unix, if it starts with a dot, it's a hidden folder. So it's still there, it's just not showing it by default. And this is a way that things that are necessary or useful for the computer, but they don't want, actively shown to the user because it's like ugly, or you just don't want people to see that. That's how it's hidden from sight. So when you were, modifying how your shell works in the install fest, you did like .bash profile or .zshellrc, and that's a hidden file, so that if I just type ls, I don't see that. But if I type ls-a, it confirms it is indeed there. And if I typed code.zshellrc, it definitely knows about it. It's a real file. And mine might look a little different than yours. But that file is as real as any other file. The hidden thing, the dot in the front, is just a convention, because things have to live somewhere. And as you can see, in your home folder, you're often gonna have a lot of things that you're like, what is that? But .ds store, that's some Mac specific thing, or .trash, I guess that's the file that represents the trash thing down here. And yeah, there's all sorts of things like that. And it's just a way that like configuration files or other things that you don't want to have to think about, that's where they live. And very often, if you like run some program like, npm is keeping track of things in its own file or folder called .npm, but you, the user, don't really need to think about it. And then, so we have ls going to show us our files, and then ls-a is one flag to show us all our files, including our hidden files. And as we saw earlier, we can have ls-l, and that shows me way more information about the files, like that. But something to show is that I could have more than one flag. So I could do that. I could say ls-l-a. That's going to show me all the files and all the information I could ever want to know about those files. So you'll see that the dot stuff is still there with all that information. But it's worth noting that if you have more than one flag, you could just do it like that. So this is going to have both the -l and the -a flag, but it's that much more concise. So that's the same thing. That's just something to point out. And that'll be true for any command in Unix. So if there's more than one flag, that is how you can call more than one flag without having to write each one separately. Okay, so the next thing we're going to do is cd, change directory. And there's a couple of things here with that. But what we want to show here first is that cd is our first example of a command that isn't just, on its own. It isn't just, okay, it also takes a flag, but it actually takes an actual argument, meaning it's going to take something specific to your own computer that changes the behavior in a way that it just wouldn't make sense without it. So if I go back here, I could type cd. It works, but nothing seemingly happens. What did I do? I changed directory, but I didn't say what. So it just doesn't do anything. But if I said change directory and then I start hitting tab, it's going to say, well, change directory where? Here's where you are. Where do you want to go? And I could say, okay, change directory to source. I can keep hitting tab and it keeps auto-completing. I want to go there. And maybe if I keep hitting tab and it doesn't show me anything, it means, okay, that's as far as I can go, meaning I hit a file that doesn't have any, or I hit a folder that doesn't have any more folders in it. So I go there and that's where I am now. If I say print working directory, it's going to tell me from the root exactly where I am. When I say ls, it's going to, show me the file that's in there. But right, so that's what cd does. cd changes directory, and we can see that there's actually we already established that there's a few other things. So like I could say cd/, and that'll change me all the way to the root. And I actually like this. You'll see that my thing shows me a lock because it's saying like you don't belong here. You don't have root access. So like there's files in here I really shouldn't be touching. And I'm pretty sure if I try to remove some of these files, it would say it would at least force me to type sudo because it's saying you don't belong here. And the other most common shortcut is CD squiggle, and that'll bring me to my home directory. So depending on who I'm logged in as, that'll bring me to my home directory. I think we don't mention this one, but there's another built-in called Who Am I that tells me who is the current user logged in to this command line system. Generally, it's just going to be you, and unless you're sharing the system with a lot of people, you'll never have to write that. But that's a quick way to get yourself. But there's some other things. So let's say I'm right here, and let's say I'm just going to go into code Platoon. I'm going to go into Tango. So this is where I am now. And if I type ls, this is all of the files and folders in this directory. But actually, here's an interesting thing. If I type ls-a, that's going to show me all the hidden files too, right? So what are the hidden files? Well, there's this .ds store thing, which is a Mac specific thing, but there's actually dot and dot. What are those? Well, actually, every single, oh, I'm sorry about that. 1 second. Weird thing. Yeah, I'm sorry. I have to teach outside today. Sorry, one of my neighbors just walked by. Yeah, so the dot and the dot are built-in things because every single folder in Unix has essentially a shortcut for itself and its parent. So dot represents oneself. So like in VS Code, when you type code dot, what is the dot? It's saying open, like call VS Code, and the argument is a directory. Well, what's the directory? Dot means the current directory. So I could also, have said, well, this, but if I'm already in a specific folder, dot will open that whole folder. And indeed, if I do code dot, it opens the Tango folder and everything inside of it in VS Code. But while it is sometimes useful to reference exactly where you currently are, even more useful is to reference your parent. So I can obviously always go all the way back to the root or all the way back to the home folder. But let's say I just want to go up one level in the hierarchy, that's dot dot. So I was in Tango, now I'm in code Platoon. And you can actually chain those. So if I went back into Tango, and let's say I went into grading and assessment 2. Okay, so I'm pretty deep in here now. If I want to go up a couple levels at a time, I could say cd dot dot slash. So slash meaning I'm now looking in that directory, dot dot, we'll go up at another level, dot dot. And what I'm saying here is I want to go up 3 levels. So if I'm in assessment 2, going up 1 level would be grading, going up another level would be Tango, going up another level would be code Platoon. So if I do this, I should now be in the code Platoon directory. So we use that all the time, cd dot dot, maybe slash dot dot, and that's just going to raise you up levels in the hierarchy. Right, so we covered all those there, and there's a little thing here to say this idea of absolute versus relative file paths. So when you're saying like squiggle or dot dot, you're saying relative to where, dot is relative to where like most of the time you're if I say like cd Tango, that's relative to where I currently am, but really behind the scenes your file system is doing that, and behind the scenes it's doing users / Benjamin Cohen, whatever it is. So every file path really is absolute, but the relative one is just for ease of use. But let's stop there for a second because I did a lot of talking. Everything we did up until now is in this section called folder navigation. So we want to open the floor for any questions about folder navigation.
I just had a question about like the /. So we really shouldn't ever need to do like the cd / and go into the root directory.
Yes and no. Yes, you are right. You should generally not need to do it because, like you see, there's the lock there. It's saying this is sort of delicate stuff. At the same time, every time you type sudo, we're going to get into that a little more when we cover sudo. But the whole point is sudo is it's saying this isn't something that's in your home directory. This is something that that affects the whole computer. And so you need to kind of upgrade your status and make sure you're someone important. You have root access. Because like when you're messing with brew, it's actually putting something somewhere that you need like special privileges for. So basically it's perfectly fine to go into this stuff and mess with it. And if it's your own computer, sudo will work, because sudo essentially means if you're registered as an important user, you can upgrade yourself to root access. But just you want to be careful with it, because once you're at this level, you could, if you deleted things, you could start deleting things that would outright break your computer. Because like the home level is everything you, the user, should access. The root level is where like Mac wants to access stuff, and that's where it stores its files and folders. So if I were to go into, you know, slash, just directly from //bin, this is where like all my programs live. Like ls, it's right there. That's ls. If I decided to remove ls, I wouldn't have ls anymore. And that's why it's kind of dangerous to mess with things at the root level. I really do wonder if I deleted ls, I think I just wouldn't have ls anymore, but that's why we're just going to be careful. We're going to recognize it's too powerful, and we're going to leave.
Is it red because you don't have permissions there, or why was everything red?
That's a good question. I'm not actually positive. So the coloring scheme is not necessarily like that's Z shell, and I don't necessarily, or oh my Z shell, and I don't necessarily know exactly why that is. If I do this, for example, I think that's a really good theory. There's a good chance it's because it doesn't belong to me. It belongs to root. And it's saying like, I don't think you should really be touching this. But that's the sort of thing where I would say, okay, let me Google. My guess would be, oh my Z shell, what does red text mean? Yeah, I don't know that I'm going to find out right away, but that is a good theory. That's a good theory. I don't actually know. Like, for instance, I have no idea why this one is in block quotes as opposed to this one. You know, the rest of them aren't surrounded by a red block, but this one is. No idea why. Okay, any other questions about the file navigation stuff? Okay, if not, we're gonna keep going. I'll look in the chat quickly. I see Eric has a question here. I think some links were messed up where some people got an older link to InstallFest. So we're gonna make sure everyone gets the up-to-date link to InstallFest. But if you look in the curriculum docs, that is gonna be like all the way up here. These should all be the correct links for InstallFest, including videos. Yeah, coming back here, file management. So that's our next thing. And we'll give another break, and I'd say like 15, 20 minutes, but we'll probably try and do all the file management stuff. So everything we've done now is how to move around the file system. But obviously it's not so useful unless you can like change things or add things or remove things. So that's what this is. So the first one is mkdir, make directory, and it takes one argument, which is the directory, the name of the new directory you want to make. So directory is just another name for folder. So if I go here, I see I'm at squiggle, I'm at home. So I could say make directory, and I'll make this directory called, you know, I'm not so creative when it comes to stuff, so the only thing that's coming to mind is example. So make directory example, and now I type ls, and indeed there's something called example here, and because it's in this like bold, we know it's a directory, and so now I can go inside of it. But you'll see it's totally blank. There's nothing in there. If I did ls-a, you'd see there's dot and dot dot in there, but otherwise there's nothing in there because make directory just makes a blank new directory. And by the same token, let's say I wanted to make a blank new file. That is this thing called touch. So make directory, you kind of do use all the time when you want to make a new folder in your file system. Touch you use a little less often because Visual Studio Code will kind of do this for you at this point, but I can write touch and say, you know, abc.xyz, and it could be whatever it wants to be. File extensions are just like the dot, you know, txt. That's just useful for other programs like VS Code or whatever to know, oh, I can open this, but it's meaningless. You can just write .xyz, and indeed we have a file there called .xyz, but it's empty. So if I were to type code abc.xyz, we open it up, there's nothing in there. It's a new file, but it's an empty file. And in reality, we probably wouldn't use touch too much anymore. Instead, we would do something like code and then say, you know, my new file.txt. And when we do that, Visual Studio Code will open it up. It'll have a new file. It will be empty. But note that like it's not saved yet. So Visual Studio Code opened it up, but that circle there means it's not yet saved. So if I go back here and I type ls, it's still not there. But because I said .txt and because Visual Studio Code is smart, it already knows what type of file I'm working in. So if I said like .py, it would know I meant a Python file. And I could just write hello world, and then I'll save it. And now indeed, if I go back here, it knows about that file. So that's what touches. Like a lot of these.
A question real quick.
Mm-hmm.
Sorry to interrupt you while you're in your
no, of course.
State. But so when you created that new directory, why did you have some that were different colors? Like, so I understand so the directory is just basically a folder.
Mm-hmm.
But like, I know, is Code Platoon also a folder for you as well?
Yeah, so the reason why some of these are pink is just because those are links. We get into this a little later, but a link is not an actual folder. It's like a shortcut on your desktop. It points to an actual folder. So if I were to type ls -l, you'll see here that it's saying like Code Platoon. Well, Code Platoon actually points to source/Code Platoon.
Okay.
And now if I went here now to source/code to source, you'll see Code Platoon is just a regular folder. But the color scheme is always like that. That's sort of like you get that with stuff like Oh My Z Shell, but by default, you like on just a fresh terminal on Mac, it's not going to give you any colors. So like the colors are just sort of a shorthand helper, but they can change system to system, and yeah.
Makes sense. Thank you. Sorry.
No, sorry. Nothing to be sorry about. Yeah, any other questions about where we are right now, or should I continue with what we've covered so far with file management is mkdir, which makes a new directory, and touch, which makes a new empty file. So new empty folder, new empty file. Yeah. Okay, so from there, we are going to move on to other useful things. So one of them would be copy. Probably obvious what that means it does. You copy some source folder to some destination folder, or a file. So you can copy a file from one to the other. So we'll do that first. Let's just say I'll go back to my main one. So I have that hello.py, and if I opened it up, it would look like, you know, well, I guess there's nothing in there, but I'll put something in there for the sake of showing it. So I can do print hello world, save it. So that's hello.py. It has, you know, this print hello world in there. And let's say I want to make a copy of it because I don't want to make a new file from scratch. I want to make a copy and modify it. So I would say something like copy source hello.py, destination, I'll call it goodbye.py. So I copied it, and now if I first I can see that if I do ls, I have something called goodbye there. And if I open it up, here it is. And now, you know, because I copied it, I already have contents in there, and maybe I change it to goodbye moon and save that. And so that's what copy is. It's what you might expect. thought I heard someone about to say something, but if not, the other thing to show is like, well, let's say I want to copy a folder. That seems like something you might want to do. So let's say I'm here, I have my, my hello, my goodbye, but let's say I want to copy the entire example folder. So I'm going to say copy example, and I'll just call it example copy. What happens? Well, we get a kind of warning or error. It says example is a directory, not copied. So you see this a lot in the CLI, and it's kind of annoying that it doesn't tell you a little more, but very often a command will work if it's a file, but if it's a directory, it's like, hey, I'm not comfortable doing this the way you said it. And the solution is to add a flag called -r. So -r means dash recursive. Recursive is an idea that we get into more as the semester goes on, but it's a pretty core computer science topic. And recursive means don't just do it for this, do it for this and everything inside of this and everything inside of this and everything inside of this. So if it's a folder, if the folder has something in it, it doesn't just want to copy it, because what does it mean to copy the folder but not what's also inside of it? So in the case of a folder, we say copy example to example copy, and also copy everything inside of it. So this will work now. And now if I go into example copy, it has all the files that were in example. So, or rather, it has copies of all the files that were in example, but with the exact same name and contents. So yeah, that's how you would copy. And most of the stuff you probably will continue to do just in File Explorer or Finder, but it's worth knowing that all these tools are here in the command line. And in reality, when you do stuff in a GUI, that's how it's really doing it. The next one would be move. So move is kind of funnily named because it's not really moving, it's renaming. So let me go back here. Let's say I wanted to move hello.py. I would say move hello.py to, another name.py. I do ls, and hello.py is not there anymore, but another name.py is there. And if we opened it up, we would see that the contents haven't changed. We just moved, or rather renamed, the file. And I believe that move works just as well for folders. But like everything else with computers, the way to know for sure is to test it out. So if I wanted to move example copy and I wanted to call it totally different name, it likes that. And now we see there's something called totally different name, and all we did was change the name of it. But for historical reasons, it's mv move. And continuing in this thing of like file management, next big one is rm, remove. So, we've created files and we've copied files and we've moved files. But we also want to remove files sometimes. So the way we would do that is we'd say, just remove goodbye.py. And now if we look, it's not there anymore. And something to note is that when you remove something like this, unlike when you do stuff in Finder, it's not going to end up in trash. It's actually gone. It's completely gone. You cannot recover it unless you really know what you're doing. And people pay a lot of money for that service of like, I deleted something, oh, it's still somewhere on the hard drive technically, because basically when you remove something on a computer, it doesn't overwrite it. It just sort of releases that memory. So something else can overwrite it if it wants. But yeah, when you remove it, you lost access entirely. And that is the basic of how remove works. But let's say I wanted to remove a folder. So when playing with this stuff, it's always good to remove something that you don't actually care about. So I'm going to remove a totally different name. And when I try and remove that, it gives me that same error, is a directory. Okay, well, the problem is that it wants me to remove it like this recursively. And that worked. But very often you'll see not just -r, but -rf. The F means forcefully. And that's because depending on permissions and these various things, it'll sometimes ask you, are you sure you want to delete that? Are you sure you want to delete that? And if you're trying to delete a folder with 100 files, it's going to ask you 100 times, are you sure you want to delete that? And so the F says, I know what I'm doing. I know what I'm doing, forcefully delete it. And so that folder doesn't exist anymore. And so we show that here. But there's one thing to show, which is almost like a rite of passage when you're learning any kind of computer science. Here's there's like what, 6 characters in there. Don't type that in, but let's read it. So we're not going to execute it, but we're going to read it. And any good operating system probably wouldn't let me do this. It would say like, hey, you don't have access rights, this or that. Remove. Okay, remove. Well, flags recursively, forcefully. So don't ask me any questions. And whatever I'm telling you to remove, if it's a folder, start at that folder and then remove everything down. Slash, the root of your file system. What this is saying is destroy my file system. I'm not going to hit enter. If we're lucky, Mac is smart enough that at the very least you could reinstall. Like, it's not going to actually delete Mac itself. So like if you were to restart your computer and hold down some keys, you're going to be able to reinstall Mac at least. This is not going to be true all the time, though. I'm pretty sure like on a Linux system, especially one that says, hey, you have full access, you're literally going to destroy your computer to the point that the hardware is unrecoverable. There's no way to talk to the hardware anymore. You destroyed everything. And so this is both the danger, but the power of the command line interface, that those like 6 letters would destroy your computer. And you don't want to do that. So basically you want to be careful anytime you're doing remove -rf, because you're saying I know what I'm doing. Anytime the -f is there, you're saying, I know what I'm doing. Believe me, just do what I say, and you might pay the consequences. Let me look at chat really quickly. Yeah, of course, the goblin, right? Sorry, go ahead.
I think you just typing that into your shell just made my blood pressure rise by like 50% looking at that.
Yeah.
Enter.
Yeah, well, I'm pretty confident Mac won't let me do that. Like, it would, even though I said forcefully, I'm pretty sure Mac would be like, dude, no.
But you
like,
don't know for 100%, right?
I don't know 100%, and you're right. And my finger could have slipped. I could have hit enter. This lecture in Zoom would just collapse. So yeah, it's something to be careful about. But again, you should know about it because there is power there. Just like in I don't know if any of you had this experience, but in like computer class in like the 5th grade, you had some kid going around saying like, press Alt F4, press Alt F4. You're like, okay, I'll try it. And you close the program. And if you're in the 5th grade, whatever you're using, you're like, I don't know how to reopen that. But yeah, you gotta, and this is the general rule of like, be careful when you execute something if you don't know what it's doing, because there's consequences, and those consequences, if they're real consequences, might be unrecoverable consequences. So especially once we get into Git, in Git, sometimes you'll get into weird situations where you're like, you just want to use the -- force flag, and that will work, but that will also just overwrite anything else. So it could be someone else did some work, you're having trouble merging it, and then you're just like, you know what, force my changes out there. We just overwrote work someone else did. Maybe it's gone entirely now. That's like kind of bad. All right, the last one in this section, we discussed it a little, but it's this ln thing, the link thing. So that's just this case of, creating a shortcut. So we're actually going to try something out that someone said earlier. So for example, let's say I have this example folder. I could say ln-s example. Maybe we're going to talk about a specific thing. So example 8, and I'm just going to name it the same thing. But the idea is that now if I type ls, I have this abc.xyz right up here. And that makes it easy if I want to like open it. And it's just like, okay, that's going to be an easy way to work with that file. But if I removed it, okay, I removed it. But if I go into example, it's still there. But what someone was saying earlier is that there's actually a different version of ln. So that -s means symbolic, which means it's a shortcut, but it's not really it doesn't really represent it entirely. So if you delete it, you're just deleting the shortcut. If I do -n and I do that same thing, so that's where, that's the source and this is the destination, what we're going to name it. Based on what that individual said, if I now remove that, it should remove the original too. So let's see. No, it didn't. Okay, so he was wrong.
Yeah,
but this is how you find out. What was that?
sorry. Yeah, it was like without any flags, but
Without any flags. Sorry.
can you create like text file, put something in it, just like test1, test original one, something like that?
Sure. Yeah, you're saying just make a text file right here and put something in it.
Yeah, just in create
Mhm.
link with it.
So you're saying I'm gonna go up here and then
create link.
I'm gonna create a link
without flag.
Exactly. And we're gonna do that and we're gonna call it the same thing, might as well.
Mhm.
And now we have that.
And
Yeah.
Can you delete the original one, first one?
You're saying go into example and delete the original?
Original one, yeah.
So you're saying delete this now?
Yeah, original one, the first one. Yeah.
Okay.
Yeah, and open the link.
So open the link like this.
Yeah.
Okay, it's still there.
It created like two different handles. Even if you delete the first one, the second one still exists.
Yeah.
But it doesn't work.
It seems almost like, okay, I think I see. Like it's like copying it, but they're always going to stay linked to each other. So unlike copying, if I copy something, I could then change the contents. But in this, it's like copying it, but if I change the contents, it's reflected immediately in the other one.
Both sides, yeah.
Yeah. But if I delete it, who knows? This is certainly stuff like if we went into that explain shell thing, it would certainly tell us more. But to be honest, you're probably not going to use ln too often. So, or I would say if you're going to use ln, just do the -s, do it that way. But yeah, that's everything for the file management stuff. So we'll open the floor for questions now. And then after that, we'll take a break and we'll come back. I see a question about the RM -R thing that it wanted to ask me. I think as long as it has at least one other folder, or as long as it's not empty, it's going to ask me that. If it's empty, it will just delete it. All right, any other questions about file management stuff? Okay, no worries. I think we're gonna take, let's take another 10-minute break. We'll come back 2:45 p.m. and then we'll talk about some other